2.3 Two random variables. Most of the interesting questions in economics involved two or more variables. Are college graduates more likely to have a job than non-graduates? How does the distribution of income for women compare to that for men? These questions concern the distribution of two random variables. Considered together, education and employment status in the first example, income and sex in the second. Answering such questions requires an understanding of the concepts of joint, marginal, and conditional probability distributions. Joint and marginal distributions. Joint distribution. The joint probability distribution of two discrete random variables, say big X and big Y, is the probability that the random variables simultaneously take on certain values, say X and Y. The probabilities of all possible open X and Y close combinations sum to 1. The joint probability distribution can be written as the function, the probability of big X equals X and big Y equals Y. For example, whether or not it is raining, affect the commuting time of the student commuter in section 2.1. Let big Y be a binary random variable that equals 1 if the commute is short, less than 20 minutes, and that equals 0 otherwise. And let big X be a binary random variable that equals 0 if it is raining and 1 if not. Between these two random variables, there are 4 possible outcomes. It rains and the commute is long, open, big X equals 0, and big Y equals 0, close. Rain and short commute, open, big X equals 0, and big Y equals 1, close. No rain and long commute, open, big X equals 1, and big Y equals 0, close. And no rain and short commute, open, big X equals 1, and big Y equals 1, close. The joint probability distribution is the frequency with which each of these 4 outcomes occurs over many repeated commutes. An example of a joint distribution of these two variables is given in table 2.2. According to this distribution over many commutes, 15% of the days have rain and a long commute, open, big X equals 0, and big Y equals 0. That is, the probability of a long rainy commute is 15%, or the probability of big X equals 0 and big Y equals 0 equals 0.15. Also, the probability of big X equals 0 and big X equals 1 and big Y equals 1, Also, the probability that big X equals 0 and big Y equals 1 equals 0.15. The probability of big X equals 1 and big Y equals 0 equals 0.07. And the probability that big X equals 1 and big Y equals 1 equals 0.63. These 4 possible outcomes are mutually exclusive and constitute the sample space, so the 4 probabilities sum to 1. Table 2.2, joint distribution of weather conditions and commuting times. Long commute, big Y equals 0. Short commute, big Y equals 1.